Hello geometers and seekers of general truths. In this video, we will apply our knowledge of the sine, cosine, and tangent ratio to solve for some missing lengths of right triangles. And one thing I want to point out is that in these right triangles, we only know one length. Only one length is known. So the Pythagorean theorem by itself is not going to be sufficient. We need to use the sine, cosine, and tangent ratios. So let's get right to it. So in this first problem here, we're going to use 53 degrees as our reference angle, and we're going to try to solve for the value of the variable a. Right, so if you look at with the 50-degree reference angle, a here is the adjacent leg of that side length, and the value that we know, right, the value that we actually know is this leg right here, which is the opposite leg. Okay? And so if we're working with the adjacent and opposite, that indicates that we should be using the tangent ratio. So remember SOHCAHTOA, tangent is opposite over adjacent. So we can write this equation up as the tangent of 53 degrees is equal to the opposite leg, which is 22, divided by the adjacent leg, which is the variable a. And then we are going to multiply both sides by a. And so we get a times the tangent of 53 degrees is equal to 22. Then divide both sides by the tangent of 53. So we get 22 divided by tangent of 53 degrees. Right? And this we can type into a calculator. 22 divided by tangent of 53, and that gives me a long decimal. It gives me like 16.578 and so on. We're being asked to round to the nearest tenth, so we'll round that off to 16.6. Now, as far as solving for the variable b, well, there's a lot of ways we can do it. We could use another trig ratio. We could use the Pythagorean theorem. And we could use the Pythagorean theorem with 16.6, but I like to go back to the original values so that if I made a mistake here, it doesn't affect my next answer. So I'm going to use still 53. I have still the opposite leg, but this time I'm solving for b, so this is the hypotenuse. So when I'm working with the opposite and the hypotenuse, that means I want to use the sine ratio. Remember, right? SOHCAHTOA. Sine is opposite over hypotenuse. So I can write this up as the sine of 53 degrees is equal to the opposite, which is 22, divided by the hypotenuse, which is b. Multiply both sides by b, and I get b sine of 53 is equal to 22. Then divide both sides by sine of 53. And again, I want to round that off to the nearest tenth. And that's going to give me approximately 27.5 as my final answer for the value of b. All right, so hopefully that clarifies a few things for you and gives you an example of how we can use these trigonometric ratios to solve actual problems. Let's go on and let's work on the second question here. This time we have a 39-degree angle, and this is our reference angle. Let's solve for C first, all right? So C here is the adjacent leg, and 37 here is the opposite leg. So we are going to, again, use the tangent ratio. So we can use tangent of 39 degrees is equal to the opposite leg, which is 37, divided by the adjacent leg, which is C. Multiply both sides by C. And then divide both sides by the tangent of 39. So 37 divided by the tangent of 39 degrees and round that final answer to the nearest tenth. So that tells us that C is approximately 45.7. And we kind of repeat the same process in solving for D. We have an opposite and we have a hypotenuse. So we want to use the sine ratio. So sine of 39 degrees is equal to 37 over D. That means that D will be equal to 37 divided by the sine of 39. All right, so put that into a calculator, and we want to round to the nearest tenth, and that gives us approximately 58.8 as that missing length. Now, looking back at both of these problems, one thing that we should check is a little bit of a sanity check, just to verify our work here. So let's see, if this angle is 39 degrees, then this angle here must be 51 degrees because the three angles have to add up to 180. This length here we said was 58.8, and this length we said here was 45.7. Well, how do we check? This doesn't mean we're 100% correct, but it means that we're on the right track at the very least, right? So in any triangle, the smallest leg should be opposite, or the smallest side should be opposite the smallest angle. 37 is the smallest side, that's opposite 39. 45.7 is the medium, the middle length, and that should be opposite of the medium angle. And then 90 degrees is the biggest angle, and you can see that's opposite of the longest length. So when you solve these problems, there's a lot of numbers flying around. At the very end, you should take a look, verify, and double check and make sure that everything makes sense. As always, thank you for watching. Ask questions if you need clarification, and have a wonderful day.